Hello, my dear students. This is again Teacher Jenny guiding you on the third module for Quarter 3 of Mathematics 7. So get ready and together let's make mathematics fun and easy. In this tutorial video, we will be having two lessons. First, parallel lines cut by a transversal. And second, angles formed by parallel lines cut by a transversal. With the learning competency, derive relationships among angles formed by parallel lines cut by a transversal using measurement and by inductive reasoning. But before we proceed to our new lesson, observe first the following figures. What can you see on the figures? Very good. They have 3 or 4 lines with points of intersection. Have you observed that all 3 figures have that line L? Okay. What have you noticed about line L and the other given lines? You're right. Line L intersects 2 or more lines at different points. That's why this line L is called a transversal. Now on this fourth figure, now on this fourth figure, we have again line L and 3 other lines, line M, line N, and line O. Can we consider line L here a transversal? Very good. It's not a transversal because it intersects the other 3 lines at exactly 1 point. So again, when we say transversal, it is a line that intersects 2 or more lines at different points. Take note of the word different. So if we go back to the 4 figures, only line L on the fourth figure does not intersect the other lines at different points. So that's what it means by transversal. Now let's have our first lesson. Parallel lines cut by a transversal. But before that, can you still remember what are parallel lines? All right, these are lines that do not intersect. Now, given 2 parallel lines, we have what we call interior and exterior parts of the parallel lines. When we say interior, this is the space inside the 2 lines. So given 2 parallel lines, the interior is between those 2 lines. But when we say exterior, it's the space outside the 2 lines. So given the 2 parallel lines here, the exterior can be on top of the first line and below the second line. Now, given 2 parallel lines and a line intersecting those 2 parallel lines at different points called a transversal, how many acute and obtuse angles were formed? All right, there are 8. Now, given those angles, can you name the interior angles? Very good. Those are the angles found between those 2 parallel lines. So all angles Inside these orange box are interior angles. We have angle 2, angle 7, angle 3, and angle 6. Now, how about the exterior angles? Very good. Of course, we have the angles inside the two red boxes. We have angle 1, angle 8, angle 4, and angle 5. Let's have another example. How about in this figure? What are the exterior angles? Very good. We have angle 7, angle 8, angle 2, and of course, angle 1. How about the interior angles? You're right. We have angle 6, angle 5, angle 3, and angle 4. And that ends our first lesson, which is all about the parallel lines cut by a transversal. Let's now have our second lesson. Angles formed by parallel lines cut by a transversal. Now observe these four figures. In each figure, a pair of angles were marked. Do you know the relationship of those pairs of angles? All right, these are pairs of angles located on the same side of the transversal. One interior and one exterior, but not adjacent. So if we're going to look at the figures, we have here on this first figure, both angles are on the left side of the transversal. Same with this second figure. And these two pairs of angles on these two last figures are on the right side of the transversal. And you look at those two angles, one of which is an interior angle and the other one is an exterior angle. And take note, they are not adjacent. When we say adjacent, they have a common ray. So if we have angle 1, it is adjacent to angle 2 and angle 3. And we call these pairs of angles corresponding angles. Now, with regards to the measurement of corresponding angles, they are congruent. So on figure 1, the measurement of angle 1 is the same as the measurement of angle 5. The measurement of angle 3 is equal to the measurement of angle 7. Let us have an example. In this figure, can you name the corresponding angles? Good to hear that. So let us name the corresponding angles. Angle 1 and very good, it's angle 3. Angle 8 and you're right, it's angle 6. Angle 7 and correct, that's angle 5. How about for angle 2? Of course, we have angle 4. So given two parallel lines and a transversal, there are all four pairs of corresponding angles. Now considering again angle 1, if it measures 125 degrees, what is the measurement of angle 3, which is corresponding to angle 1? Very good. It should also be 125 degrees. So always remember, corresponding angles are congruent. They have the same measurement. Next, we have these two figures. What can you notice about the marked pairs of angles? Very good. They are pairs of angles on alternating sides of the transversal but on the interior of the parallel lines. So on this first figure, we have angles 3 and 6. Note that these two angles are both interior angles and they are not on the same side of the transversal. These kinds of pairs of angles are called alternate interior angles because they are alternating and at the same time they are interior angles. Now, with regards to their measurement, alternate interior angles are congruent. So like corresponding angles, alternate interior angles are also congruent. Let us have this example. Can you name the alternate interior angles? Very good. We have angle 2 and angle 6. And of course, we have angle 7 and angle 3. Take note, given two parallel lines cut by a transversal, there are two pairs of alternate interior angles. Now, if angle 7 measures 135 degrees, what is the measurement of angle 3? Very good. Since angle 7 and angle 3 are alternate interior angles, they must have the same measurement. So this also measures 135 degrees. Next, we have these two figures. What can you notice about the two marked pairs of angles? Alright, these are pairs of angles on alternating sides of the transversal but on the exterior of the parallel lines. So this time we have angles on the exterior of the parallel lines. So if a while back we called the pairs of angles on alternating sides of the transversal on the interior of the parallel lines as alternate interior angles, what do you think can we call these pairs of angles on alternating sides of the transversal on the exterior of the parallel lines? Very good. They are called alternate exterior angles. Now, with regards to their measurements, alternate exterior angles are congruent. Let's have an example. Can you name here the alternate exterior angles? Very good. We have angle 1 and angle 5. And of course, the second pair, we have angle 4 and angle 8. So, if angle 8 measures 65 degrees, what's the measure of angle 4? You're right. It should also measure 65 degrees because they are alternate exterior angles. And like what we have said a while back, alternate exterior angles are congruent. Next, we have these two figures. What can you observe about the marked pairs of angles? Very good. These are pairs of angles located on the interior part of the parallel lines and on the same side of the transversal. So as you can see on this first figure, angle 3 and angle 5 are both on the interior of the parallel lines, and they are both on the left side of the transversal. And we call these pairs of angles the same side interior angles. And as shown on the figure, these pairs of angles are not congruent. They are supplementary. Can you still remember what supplementary is? Alright, when we say supplementary angles, these are angles whose sum is equal to 180 degrees. Let's have an example. Given this figure, can you name the same side interior angles? Very good. We have angle 2 and angle 3, and of course, we have angle 7 and angle 6. So, if angle 2 measures 65 degrees, what's the measurement of angle 3? Very good. It's 115 degrees. Because angle 2 and angle 3 are same side interior angles, so they are supplementary. So if we subtract 65 from 180 degrees, that gives us 115 degrees. Or if we add 115 degrees and 65 degrees, it gives us 180 degrees. Next, we have these two figures. What can you observe about the given marked pairs of angles? You're right. These are pairs of angles located on the exterior part of the parallel lines and on the same side of the transversal. So if we're going to consider our second figure with marked angle pairs, angle 2 and angle 8, note that those two angles are both on the right side of the transversal, and they are both found on the exterior part of the two parallel lines. So if we call the pairs of angles a while back as same side interior angles, what do you think can we call this kind of angle pairs? You're right. These are called same side exterior angles. And like same side interior angles, the same side exterior angles are also supplementary. Let's have this example. Can you name here the same side exterior angles? Very good. Angle 1 and angle 4. And of course, we have angle 8 and angle 5. So if, say for example, angle 1 measures 108 degrees, what's the measurement of angle 4? You're right. It's 72 degrees. Since 180 degrees minus 108 degrees is equal to 72 degrees. But aside from angle 4, we can also give the measure of the other angles given only the measurement of one angle. So if we're going to give the measure of the other angles, let's have angle 3 first. because this angle and this angle 3 are corresponding angles. That means they have the same measurement. So angle 3 also measures 108 degrees. Now, since angle 2 and this angle measuring 72 degrees are corresponding angles, then angle 2 also measures 72 degrees. Now, considering again this angle with measure 108 degrees, note that this angle and angle 5 are alternate exterior angles. Therefore, they are congruent. That means angle 5 also measures 108 degrees. And since this angle and angle 7 are corresponding angles, so the measure of angle 7 is also 108 degrees. And of course, since angle 8 forms a linear pair with this angle or this angle, so that means the difference between 180 degrees and 108 degrees is the measurement of angle 8. So we have angle 8 that measures 72 degrees. And take note, this angle is vertical to this angle. Therefore, they have the same measurement. Same is true with these two angles. And it also follows that this angle, angle 6, measures 72 degrees because this angle is corresponding to this angle which measures 72 degrees. So those are the different kinds of angle pairs formed by parallel lines cut by a transversal. But before we end this video, always remember that parallel lines are lines that do not intersect. And a line that intersects parallel lines or any other two or more lines at different points are called transversal. And given two parallel lines cut by a transversal, there are 8 angles formed. And those angles have 5 relationships of angle pairs. We have corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles, and same side exterior angles. And take note that these first 3 relationships of angle pairs are congruent or they have the same measurement. But these two last pair of angles are supplementary, which means the sum of each pair of angles is equal to 180 degrees. That's all. I hope you have learned a lot from this video. Thank you for watching.